So you mentioned a couple of the different FROs that you guys have been starting, and some of the things that you're interested in with these. So do you have like a list of these FROs? Do you have a favorite? Do you have something in particular that you're interested in? And kind of like give me the layout of what's going on now with all these different organizations.
So again, we have two that are convergent research FROs that are both part of this umbrella organization, Convergent Research, in the Schmidt Futures Network, which will eventually also grow to have other funders and other projects. So one of those is about brain mapping, or really it's about the technology of brain mapping, and it's specifically about technology that's kind of a couple steps out from the way we currently mostly do brain mapping. So mostly brain mapping at the sort of deep synaptic level of connections between neurons. That's mostly done with this method called electron microscopy, which is super high resolution microscopy, but it requires you to make very thin slices of the tissue, and it kind of is a very black and white. You're basically either saying, is this pixel on the cell membrane or is it not on the cell membrane? And that's that you don't see which molecules are there. So this FRO E11 Bio is trying to develop a brain mapping technology that's still high enough resolution to see synapses and connections, but doesn't require that thin slicing. Makes it easier to see very long distance connections of neurons, like if one neuron originates here and then it sends the synapse over to the other side of your brain, and then that it connects there. That's something very hard for the electron microscope to do because it would have to slice through lots and lots of distance in between, and then also to see molecules in there. So that's a lot of biochemistry. It's a lot of virology, molecular biology, and then some kind of system development for that. Then we have another one that's about tools for engineering unusual microorganisms. That's called Cultivarium. And the observation there is just that, mostly the microorganisms that get studied and engineered by scientists are just very few, E. coli, yeast, and a few others. And what if you had better technologies for more rapidly kind of onboarding a new organism to be engineered? And then we have this sort of FRO-inspired project, the Rejuvenome, that's doing a large study of the biology of aging in mice and trying to understand sort of robustly what are the features that are shared across different aging interventions, what's really going on in different parts of the body in a robust way with anti-aging. So those are three that we have going now. And then we're very interested in potentially any area where there's a FRO-shaped problem that hits an important bottleneck, but I don't know, maybe Anastasia can talk about some of the specific areas that we're most excited about. Yeah.
I think not specifically, maybe like a broad cut would be that good fits often fall in the category of like very large data set that no lab or institution is right now incentivized to make. So the Rejuvenome is an example of this. It's a big multi-omic study in longevity across many different interventions. Platform technologies that they themselves may not be profitable, or like their use is like, it's not a very clear line between their use and like the study that comes out of it, but that would then enable further studies and further companies. Or potentially just like very large experiments that are hard to run. So like climate change experiments or things like that, where you need to both develop the tooling and then run that experiment, are kind of the three most obvious buckets, but they aren't the only buckets that FROs will fall into. And then I think that we're really kind of area agnostic. We're considering one in the math space. I probably shouldn't reveal too much in anything right now, but like we're considering one in the math space. We're considering a couple climate change ones. We're considering some things in biosecurity, maybe like a physics FRO. So I think we're really agnostic in the area. We're really excited about things that could make a significant impact, either in like scientific advancements or just make the world a better or safer place.
I mean, something that's common between a lot of those is there are areas where you sort of see more or less just like activity in terms of companies, right? So like it's definitely possible to do a company to make like a new kind of solar cell. It might not be very easy to make a company to create a data set to help us understand how ecosystems adapt to climate change or something like that. That's less of a product or service, but it still like might require a scalable, operationally intensive team. Biosecurity has a lot of market failures in it of various kinds, or sort of things where you need to be planning for some very long-term outcome. reducing risk from something that's much more long-term tail risk kind of events. And yeah,
I think they're just generating public goods. I think so. There's this model, which is that a startup is a long time away, which I think is how you could look at E11 Bio, is that there are probably eventual things that might be profitable that come out of that, not within convergent research, but like follow-on companies. That is, there are other things like the Rejuvenome is probably just a public good. Like it would be very hard to spin out a company out of that.
Or like the whole point is that you're releasing this data set so that people will just understand that. And then it's very hard to capture value from those things, but you need a kind of somewhat startup-like approach to generate that value.